Okay, this is the version B practice exam for the final exam in Math 1060. So we have a given angle, 2 pi thirds. We need to find positive and negative coterminal. So coterminal angle, if you recall, its terminal side is at the same spot as the terminal side of this given angle, meaning it's just a difference of 360 degrees, or in this case, 2 pi radians. So to find a positive and negative coterminal angle, you simply add and subtract 2 pi to the given angle. So we have 2 pi thirds. To find another positive coterminal angle, we can just add 2 pi. So 2 pi thirds plus 2 pi, we can change 2 pi into 6 pi over 3. So 6 pi over 3 plus 2 pi over 3 is 8 pi over thirds. And then we could do a similar operation to find a negative coterminal angle. We just subtract 2 pi. And again, this would be 6 pi over 3. So 2 pi minus 6 pi would be negative 4 pi thirds. The reference angle. So um, again, the location of this given angle theta, 2 pi thirds is in quadrant 2. It's right about there. So then the reference angle will be the difference between the terminal side of the angle and the nearest x-axis. So if this is 2 pi thirds and the nearest x-axis is pi radians, then the difference between them is pi thirds radians. So the reference angle is pi over 3. And now for part C, we convert 2 pi thirds into degrees. So we're going to multiply this by the conversion factor where pi radians is in the denominator and 180 degrees is in the numerator. This turns into 360 divided by 3, which is 120 degrees. We know that cotangent is negative 12 over 5 and cosine is positive. So cosine is positive in quadrants 1 and 4. Cotangent being negative means that this angle theta is in quadrant 4. So cotangent gives us the x value and the y value. And since we're in a quadrant 4, it's the y value that's negative. So this is negative 5 and positive 12. To find cosine, sine, and cosecant and secant, we need to find the r value. So r is equal to the square root of x squared plus y squared. So we can find now sine theta. Let's see, we know cosine theta, we need to know tangent. Tangent's easy. Tangent's just the reciprocal of the cotangent, so that's going to be negative 5 twelfths. But the definition of sine is y divided by r. So the y value is negative 5 and r is 13. Cosine is x divided by r. And now cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. Okay, question 3. It is true that inverse cosine and cosine are inverse functions. However, inverse cosine is only the inverse function of cosine if we have values that were in the defined domain for cosine. So cosine, if you remember, was defined between 0 and pi. 4 pi thirds is not in that defined domain. So this is not the case where we can simply cross out the inverse cosine and the cosine. So what we first do is evaluate cosine of 4 pi thirds. So that's an angle from the unit circle. So at 4 pi thirds, the cosine there would be negative 1/2. So we can replace cosine of 4 pi thirds with negative 1/2. So now we have inverse cosine of negative 1/2. And in the defined domain, which is from 0 to pi, we look for an x value that's negative 1/2, and that happens at 2 pi thirds. So I'm going to take the left side of this identity sign. Let's say it's sine x times the secant of x. And our goal is to change this into the tangent of x. So I'm going to use reciprocal identity for secant and change this into 1 over the cosine of x. I'm just going to leave sine x as it is. Then multiply those two expressions together. Sine x times 1 over cosine is sine x over cosine x, which is equal to the tangent of x. And then we have verified the identity. Okay, so question 5. The speed of the tip of the blade in miles per hour is a linear speed. And we have a complete revolution every 2 seconds. That's going to help us find angular speed. So we have linear speed is equal to the radius times omega, where that's the angular speed. Now, angular speed is in terms of radians per unit of time, so radians per second or something like that. So we need to convert this 1 revolution every 2 seconds into an angular speed. So we have 1 revolution every 2 seconds, and 1 revolution is equal to 2 pi radians. So we have the angular speed is pi radians per second. Now we can find linear speed. V is equal to the radius, which is 21 feet, times the angular speed, which is pi radians per second. And this is going to give us 21 pi, but it's in feet per second. We need to be in miles per hour. So we can continue to multiply by some conversion factors to cancel out feet and seconds. So 60 seconds is 1 minute. And then we can, so that cancels seconds. And then we can cancel out of minutes by multiplying by 60 minutes is equal to 1 hour. So now we're in feet per hour. So we have to cancel that feet unit of measure. So 5,280 feet is equal to 1 mile. So now we cancel feet. We have to compute 21 times pi times 60 divided by 5,280. And from that, we get roughly 44.98 miles per hour. And my apologies, it looks like question 6 did not receive the change from unit or from the practice exam A to practice exam B. So this is the incorrect problem. What it should have been Okay, so that's what it should have been. My apologies for the confusion. So first we have the alpha plus beta, the sum identity for the sine. So sine of alpha plus beta is equal to sine alpha cosine beta plus sine beta cosine alpha. So we know that sine alpha is -4/5 in quadrant 4, so we need to find, and we know the sine of beta. We know sine alpha, sine beta. We need to find cosine alpha and cosine beta. So if sine alpha is -4/5, then cosine alpha, and we're in quadrant 4 here, so cosine's positive. Cosine alpha is going to be 3/5, positive 3/5, and that's just a squared plus b squared equals c squared, where a squared plus b squared equals c squared there. And then if sine beta is equal to 12/13, and this is in quadrant 2 where sine is positive, then cosine beta is going to be -5/13, because in quadrant 2 um, cosine's negative. So in putting all of these values into this identity, we're going to have sine alpha, which is -4/5, times cosine beta, -5/13, sine beta, just 12/13, plus cosine alpha, which is 3/5. For question 7, find the sine of 2 theta. So the sine of 2 theta is equal to 2 sine theta cosine theta. Now we know the sine, well, we know the tangent of theta rather. So from that, we need to determine what sine and cosine of theta are. So if tangent of theta is equal to 15/18, then so tangent of theta is y/x. So if this is y and that's x, then we need to find r. R is equal to, there's a little typo there, 15/8, not 15/18. There we go. So r is equal to the square root of x squared plus y squared. So if we add 15 squared to 8 squared into that square root, we get 17. So then the sine is y/r. This would be 15 17s, but when you consider that it's between pi and 3 pi halves, that's in quadrant 3, so sine has to be negative. Cosine theta is x/r, so this would be -8/17. So then 2 times the sine of theta times the cosine of theta is equal to 240 over 289. So sine of theta over 2 just need to determine if it's the principal square root or the negative square root. So it depends on where theta over 2 is. If we divide everything here by 2, then we get pi halves is less than or equal to half of theta, which is less than or equal to 3 pi 4s. So this is pi halves, which is 90 degrees, to 3 pi fourths, which is halfway to 180. We have 90 to 135. So this is in quadrant 2. So theta over 2 is in quadrant 2. If we take the sine of an angle that's in quadrant 2, we're going to end up with something that's positive. So we need the principal or the positive square root of this. So 1 minus the cosine would be 1 minus negative 8/17. So 1 minus negative 8/17 is 25/17. So then 25/17 divided by 2 is 25/34. So it's 5 divided by the square root of 34. Okay, so with secant, there's no amplitude, but we can find the period and the phase shift. So period of secant is 2 pi divided by b, where b is this value here in front of theta, so it's 1/2. And then the phase shift is the opposite of c divided by b. So this is 2 pi thirds divided by 1/2. It's equal to 4 pi thirds. So we're moving to the right 4 pi thirds units. So let's say that this is 4 pi thirds. We also move up 2 units. And the period is 4 pi, so one cycle ends after 4 pi. And they want us to graph here 2 complete cycles. So we'll end another one out there. So the distance from this new point, this is the new center, 0, 0, that's been moved to the right 4 pi thirds and up 2 units. From here to here is 4 pi, but we're starting at 4 pi thirds. So if we have 4 pi thirds plus 4 pi, then that's 16 pi thirds. And then if we have 16 pi thirds plus 4 pi, we get 28 pi thirds. So we cut both of those intervals in half and then cut each of those halves into quarters. And we're graphing secant, which is related to this cosine graph. So the cosine graph is going to start at the top of, if it were cosine, it would have an amplitude of 3. So it would start at the top of the amplitude, which is right here, come down through the midpoint, and then be at the bottom of the amplitude up to the midpoint. And then there's one cycle of the cosine, and then it repeats. So if this were a cosine function, it would look like this. So then there's a vertical asymptote every time it crosses through the midline. And then finally, the secant function flips upside down at the highest and lowest points. So I'm going to add, or rather subtract, this 3 sine theta over to here. So subtract 3 sine theta. And then factor out a cosine theta. So this side of the expression and that side both have cosine. So if I factor cosine out of itself, that leaves a 1. Factor cosine out from here, that leaves root 2 times sine theta. So this is called the zero product property. Now, if this multiplied by this is equal to 0, that means both this factor, cosine, is equal to 0, and then this factor is equal to 0. So we're solving these kind of separately. So the one on the left, cosine theta is equal to 0, means that theta is equal to the inverse cosine of 0. So we can use a unit circle for that. So the cosine is equal to 0 on the unit circle at pi halves and at 3 pi halves. On the other side here, I'm going to subtract this 1 over. And then divide it by negative root 2. And then just change the format of this. So sine theta is equal to square root of 2 over 2. And then inverse sine on both sides. So on the unit circle, the inverse sine is equal to root 2 over 2 at pi fourths. And 3 pi fourths. Question 10. Okay. So I'm going to subtract this sine squared over to the left. So 2 plus cosine squared minus sine squared. And it's helpful to have the trigonometric expressions sometimes. Sometimes it's helpful that they're all the same trigonometric function. Here we have cosine and sine. And it doesn't look like I'm going to be able to combine these anyway, so I can factor out. So in question 10, I was able just to factor out a cosine, or question 9 rather, I was able to factor out a cosine. Doesn't look like that's going to be the case. So I'm going to take sine squared and change that into 1 minus cosine squared. Now they're all in terms of cosine. And even though this is cosine squared, it's still a cosine function. It's the same argument inside as well. They're all in terms of theta is the argument. So combine some like terms here. 2 cosine squared theta plus 1 equals 3 cosine theta. Now I'm going to subtract that 3 cosine theta. And now we have this trigonometric expression here that's similar to a trinomial, like a quadratic expression. So what we talked about um, in unit 2, I believe it was, is if we had something like, let's say we had 2x squared minus 3x plus 1 is equal to 0, then we could just factor that trinomial into two factors and solve that way. That's the approach we're going to take here now. I'm going to factor this. And maybe I should have kept that previous quadratic just as an example. So again, if this were something like 2x squared minus 3x plus 1, that would factor into 2x minus 1 and x minus 1. So using that as our guide, so to speak, we could factor this into 2 cosine theta minus 1 and then cosine theta minus 1. And this is again is that zero product property. If this multiplied by this is equal to 0, then each one of these factors can be set equal to 0. So 2 cosine theta minus 1 equals 0, and cosine theta minus 1 equals 0. So here we have cosine theta equals 1/2, and here we have cosine theta is equal to 1. So theta would be inverse cosine of 1/2, which happens on the unit circle. We have x values of 1/2 at pi thirds and at 5 pi thirds. And then over here, theta is equal to the inverse cosine of 1. We have an x value of 1 at 0 radians. For question 11, find the distance from A to C, the side length between A and C. So since it's across from angle B, I'm just going to call that side B. We need to find the length of side B. Now we've been given two angles here and the side in between them. So this is angle side angle. And that's a case of the law of sines. So I'm going to find side B over sine of angle B. And then I have to have a complete ratio over here, meaning I have to know the numerator and the denominator. So the only other side I know is 44. So then I have to know the sine of the angle across from it. So I need to find that missing angle, but it's a triangle here. So if we add the two, 31 and 18, and then subtract that from 180, that'll give us the measure of that missing angle there. So that's going to be 131 degrees right here. So solving this proportion by cross multiplying, we have B is equal to 44 this is 30 point, let's see, what does it round it to nearest tenth? So 30.0 miles. Question 12, this is a side angle side triangle, so that's the law of cosines. The tricky part about a problem like this is in order to find a lot, or in order to find a missing angle using law of cosines, you have to know all three sides. So there's going to be two parts of this problem. First, even though they're not asking for it, we need to find side A using law of cosines. And once we know all three sides, then we can find that missing angle. So I'm going to find side A first using law of cosines. A squared equals b squared plus c squared. And then the angle across from side A is 35.3. So if we square root that, we get 9.8. So now we know all three sides. So at this point, we could actually use either law of cosines or law of sines to find that missing angle. We had to use law of cosines first to find this missing side. But then we could use law of sines or law of cosines. Now at this point, I'm just going to use law of cosines. Let's see. Let's do, if we're trying to find angle B, then we start with b squared in the law of cosines. So this is going to be 14.8. And then a squared plus c squared. So then you would subtract these two over the left and then divide by -2 times this. So that's equal to -0.488. And the inverse cosine of -0.488 means that angle B is equal to 119, 119.2. When we have side, 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 and we want to find the area, then there's this formula here, where S is the semi-perimeter. So if we add all three lengths and divide that by 2, we get 20.35. So then 20.35 replaces all the values of S, and then A, B, and C are just the lengths of that, the sides there, and the area is the square root of 6,305.7, and that is roughly 79.4. So to find roots using De Moivre's theorem, we need to write the complex number in polar form. In rectangular form, the real part is 32, the imaginary part is 0, so it's 32 plus 0i. In polar form, that becomes the r, the distance, the modulus from the origin is 32 units, and the angle is 0 radians because it doesn't have an imaginary part, so it's 32 CAS 0. And then if we're going to do the fifth roots, then it's z the 1/5 equal to, this is De Moivre's theorem, which is on your formula sheet, 32 to the 1/5 times cosine plus I sine of the argument 0 divided by 5 plus 2 pi fifths times k, where k is equal to 0, 1, 2, 3, and 4. So for the case when k is equal to 0, we have 32 to the 1/5, which is 2. There's a cosine plus I sine. 0 divided by 5 is 0. If k is equal to 0, then this is 0. So this is cosine plus I sine of 0. If it's 2 times the cosine of 0, I times the sine of 0. Cosine of 0 is 1. Sine of 0 is 0. So this is 2 times 1, which is 2. When k is equal to 1, we have 2 times the cosine plus I sine of 0 divided by 5, which is 0, plus 2 pi fifths. And then we have 2 times the cosine of 2 pi fifths plus I sine of 2 pi fifths. Cosine of 2 pi fifths is 0.309. The sine of 2 pi fifths is 0.951. So then we distribute 2 to both of those. So for 2 times 0.309, that's 0.618. And then for 0.915 or 951, it's 1.902. Okay, for in case when k is equal to 2, 2 pi fifths times 2 is 4 pi fifths. This is cosine of 4 pi fifths is negative 0.809. The sine of 4 pi fifths is 0.588. So if you multiply each of those by 2, we get negative 1.62. I'd say negative 1.618 and 1.176. For the case where k equals 3, we have 3 times 2 pi over 5, which is 6 pi over 5. So cosine of that is negative 0.809. And the sine is negative 0.588. That's just going to be the conjugate pair for this one. So we're going to have negative 1.618 minus 1.176i. So the the remaining one, W4, when k is equal to 4, if we think about complex roots, this was a topic from Math 1050. Complex roots always come in conjugate pairs. So you see this one, negative 1.618. The difference here is just plus or minus. So anytime we have a complex root of a number, they always come in a conjugate pair. These two form a conjugate pair. So the one that's missing is we don't have a conjugate pair for this complex root. So the final root there is going to be 0.618 minus 1.902i. So we have all 5 of the roots. Question 15, we're first going to convert all of the complex numbers there into polar form. But that one's in quadrant 4. So it's going to turn into 7 pi 4s. So it turns into 2 square roots of 2. And then the other one, that one's in quadrant 2. So if we subtract that from pi, so this is 1.893 radians. So in polar form, okay, so now we're ready to divide these two complex numbers. When you're dividing complex numbers in polar form, divide the modulus here. So the 2's are going to cancel. So it's square root of 2 divided by the square root of 10. And then you subtract the argument. So 7 pi 4 is minus 1.893. And that's 3.605 radians. So we need to convert that back into rectangular form. So if we do cosine of 3.605 multiplied by root 2 over root 10, we get negative 0.4. And if we do sine of 3.605 times root 2 over root 10, that's negative 0.2. All right, the component form is going to be the the difference of the two horizontal components, and you have to subtract the second one from the first one. So it's -9 minus -2, which is -7. And then you subtract the vertical components, -2 minus 3. So it's -7, -5. So then the magnitude is square root of 7 squared and 5 squared. It's 49 plus 25, it's squared to 74. And then the direction, so that's going to give us an angle in quadrant 1, which is 35.53. The vector, the terminal point there of that vector is in quadrant 3, so we add 180 to that, we get 215. It's actually rounded up to 0.54. Oh, the angle between the two vectors is the ratio of the dot product and the product of the two magnitudes. So dot product is a combination of the product of the two horizontal components added to the product of the two vertical components. -128. Magnitude of u is the square root of 100 is the square root of 113. Magnitude of v that's the square root of 145. So dot product is -128. So simplifying that, this is -9.99969. Pretty close to -1. You do the inverse cosine on both sides of that, you get 172.87 degrees. And finally, we need to convert this into polar coordinates. So r is the square root of the x value squared plus the y value squared. So 2 times the square root of 2 squared, this is 4 times 2, that's 8. And then theta is the inverse tangent. But in rectangular coordinates, this would have been in quadrant 2. So that's going to be 3 pi 4's radians. So the point is r value of 4 and a theta value of 3 pi 4's.